Well, hey guys, back on this TDA2822M board. If you watched the last video, you know that it had excessive distortion, and I really wanted to see what the problem, why is that happening? You know, that's really too much for an audio amplifier. You know, modern integrated circuit audio amplifier shouldn't be doing that. So I figured I'd do some mods here. First thing is I put a socket on the board. That way I can swap out my different TDA2822 ICs and compare them. Normally I wouldn't do this because it prevents some of the heat getting out of the chip, but I think we're okay just for this test. I also changed out the output capacitors. These are 470 microfarad, 16 volts. These are the same values as well. These seem a little bit leaky. See if the camera will get a focus there. The chip on the left is, it's about a 30-year-old IC, back when ST Microelectronics was called SGS. And of course the one from the kit, if I can tilt it, maybe you can see the numbers better, has the ST, or the I should say has the more modern ST logo that's laser etched. I'm holding a magnifying lens up to the camera. You can see it more clearly. Notice how the chip on the left has much thicker leads. ST Microelectronics used a heavier lead frame on their audio ICs because it helps get the heat out away from the chip inside much better than the thinner ones do. So that does make the IC that came with the kit more suspect. So I've plugged in the IC that originally came with the board and stuck this little heatsink on there because it gets pretty hot. Oh, we have a Marauder on the bench. The kitty bench Marauder had to come in and get into the video. He's going to ham it up for me. Going to ham it up for us, aren't you, Snickers? Anyway, so I suspect we'll see the same results from the last video. Okay, we're all powered up, connected to our 8 ohm loads to both channels. There's clipping. Let's tune out the clipping. It's kind of touchy, that volume control. Okay, I have it tuned in there, so we're getting about 2 volts RMS, which would be a half a watt into an 8 ohm load. Looking at distortion, again we have our 4.5 kilohertz pilot signal and the 1 kilohertz fundamental. There's that huge second harmonic that goes off the screen. I figured it was around 8%. And there's some other nodes, but they're not that significant. Okay, so I'll swap the chips out and see how the other one performs. Okay, I've put in the older chip, the one that I think is authentic. So I'll adjust to the clipping point. Right about there. Look at that, we are getting more signal out of this one. And that's 2.38 volts RMS. 2.38 squared divided by 8 ohms. Yeah, we are getting more output. Getting 700 milliwatts. So already that is a pretty decent improvement. And here's the distortion. Notice that that second harmonic is a lot less. If this is 1%, then this would be about 2%. So we're 1/4 the second harmonic distortion that we had before. Still surprised. I would think it would be smaller yet, but this chip does have a lot of gain, 40 dB. So, I'm not sure they can get the distortion super low, but it is doing much better than the other IC. Well, that pretty much confirms it to me. Higher output power, lower distortion. it had thicker leads on the authentic one. Pretty much tells me that the IC they're using here is just a counterfeit piece of garbage. Well, that takes care of that. Thanks for watching. Is this focused? Okay, we'll turn the chip thingy on.